In this video, we will be applying both factoring and rationalization to eliminate indeterminate forms. My name is Janine Ko and I make educational videos like this. If you're interested in seeing more, you know what to do. Please subscribe to the channel, make sure to hit that notification bell, and give me a thumbs up. For this example, we look at limit when x approaches 0. Right off the bat, when we apply direct substitution, by plugging in 0 into x, we get 1 over 0 minus 1 over 0, and hence this is infinity minus infinity, which is one of the types of indeterminate forms. And as you know, indeterminate forms are problematic, so we need to think of a way to eliminate this type of indeterminate form. And right off the bat, we see that these are two fractions. Therefore, we have to combine them into a single fraction before we apply rationalization. So we cross multiply 1 times x to get x for our numerator. Multiplying x times x square root of 1 plus x, we would get x times x square root of 1 plus x for our denominator. Make sure you have that subtraction symbol because it's in between the two fractions, so you have minus in your numerator. Before you multiply x square root of 1 plus x times 1, so this is x square root of 1 plus x. Now notice, if you were to evaluate your limit when x approaches 0 at this point, it's still problematic because when you apply direct substitution, by plugging in 0 into your x, you get 0 over 0, which is an indeterminate form. Therefore, we still need to apply a technique, which is rationalization. In that case, we will be rationalizing our numerator by multiplying this fraction in orange to its conjugate. So this would be times, let's use a different color just because I think red is very close to orange. So we would have to multiply this to its conjugate, which is x plus x square root of 1 plus x. And this is x plus x square root of 1 plus x. So the idea of conjugates is just the opposite sign of your expression. So in that case, if you have x minus x square root of 1 plus x, its conjugate would be in the form of a plus symbol. As a result, we see that this is in the form a minus b times a plus b, and hence we can apply difference of squares, which is a squared minus b squared, and this is equal to a minus b times a plus b. Rewriting our numerator, we would get x squared minus x squared times 1 plus x, and squaring b actually gets rid of the radical of 1 plus x. So this is all over the denominator, and because we're multiplying this and this, we would have x squared square root of 1 plus x multiplied to x plus x square root of 1 plus x. And if we were to evaluate our limit at this point, it's still problematic because it will result to an indeterminate form. So expanding our numerator, we would get x squared minus x cubed all over x squared square root of 1 plus x times x plus x square root of 1 plus x. We can cancel out x squared minus x squared because this results to 0, and hence we're left with negative x cubed all over x squared square root of 1 plus x multiplied to x plus x square root of 1 plus x. And again, if we were to evaluate our limit at this point, it will still result to an indeterminate form through direct substitution, which is 0 over 0. So we need to expand our denominator, and we would have to keep our numerator, which is negative x cubed all over x cubed square root of 1 plus x cubed times 1 plus x. And as you notice, we do have a greatest common factor x cubed in our denominator, and hence we're able to factor that out and ultimately cancel out x cubed in both our numerator and our denominator. So this is negative x cubed all over x cubed times square root of 1 plus x, and this is plus 1 plus x. Canceling out x cubed in both our numerator and our denominator, we are left with negative 1 all over square root of 1 plus x plus 1 plus x. Now this is the time you evaluate your limit when x approaches 0. You take the limit when x approaches 0, using your modified expression, negative 1 over square root of 1 plus x plus 1 plus x, and apply direct substitution. We get negative 1 over square root of 1 plus 0 plus 1 plus 0, and hence we get negative 1/2.